So yes, welcome. I'm Dan Higgett, and along with my brother Oscar, we are Innovate Audio, the creators of panLab 2, which is a spatial audio mixing solution designed to work exclusively and extensively with QLab. So in today's webinar, we're going to go, this is a real introduction, so we're going to go over the basics, and then we're going to go into some practical applications of panLab 2 and how to incorporate panLab 2 into your workflow when working with QLab. So yeah, so we're going to start with some concepts, so maps, zones, and speakers. We're going to move on to some practical applications of panLab 2. So we're going to look at tuning your sound system whilst incorporating panLab 2. And then how to incorporate panLab 2 into your sound design workflow when you're working on production. And we'll finish off with some more advanced functionality, such as dynamic spatialization. That's how we actually animate a sound around your sound system, move a sound around. And some more advanced functionality. Derived outputs allow us to work with low frequency energy elements of a sound system, for example, in a spatial audio environment, and we will end up with a Q&A at the end. If you've got any questions whilst the presentation's going on, if you could put them into the chat, Oscar will be monitoring the chat, and if it's something that I've not made very clear, that would be better to kind of jump in, he can jump in and point them out to me, and if not, we'll just save it for the end as part of a Q&A session. So that would be fantastic. So let's just jump right in. So what is panLab 2? This is a spatial audio mixing solution, and it's designed to work seamlessly with QLab. So we really saw a gap in the market. Spatial audio and live sound has started off as something that has been only the kind of preserve of like really high budget productions, and is something that only a few people really had access to. And we and then obviously there's been a few more options, but they've all required quite a lot of time and money to kind of get working. And we really wanted to create something that not only was more accessible financially, but also didn't take very long to set up. So our kind of whole goal when we were creating this product was we wanted people to be able to be set up with spatial audio in like 5 minutes flat. So every time we've made a change to the software, this has really been our primary objective. And so there's some more advanced functionality that obviously is going to take longer to set up and use, but we want you to be able to wherever you are, if you're using QLab, you should be able to use this software in 5 minutes or less. You should be able to pan sounds around in a spatial audio environment. And we're also the only spatial audio solution, I believe, that doesn't require any additional hardware or software to be running during performances. So everything spatial audio related with panLab 2 is actually stored as kind of Q output levels within the QLab queues themselves. So you can kind of set up your system, set up your design using panLab 2, and then walk away and never load up panLab 2 on your production again, and you'll still get the benefit of having worked in a spatial audio environment. So that's the kind of background of the software. Let's have a look at some panLab 2 concepts. So a map. A map is the kind of wrapper, the container that contains all of the objects within your panner, which are namely loudspeakers and QLab queues. So it's literally a map of your sound system. Speakers within a map, we organize into different zones. So our algorithm that we've created in this kind of bid to create something that you can get going in 5 minutes does a lot of the work for you, and it works out the relationship between your loudspeakers based on where they are, but it still needs you to set your loudspeakers up into zones. And you can think of a zone as a set of speakers that you might want to pan a sound around. So for example, if you're sitting in an auditorium, you might have a couple of loudspeakers on your proscenium, and then maybe some side and rear surrounds behind you. That set of speakers might logically be a zone, in that you're in a central position and you want to pan sounds around those speakers. You can also think of a zone as a polygon shape, where each speaker is a point on the polygon. So when you put speakers onto the map in a zone, you're kind of creating a shape on the map that we actually visualize for you. And finally, you can think of a zone as a layer of paint on a canvas, and your canvas is your map. And your map can contain multiple zones, and each zone is layered on top of other zones. So in that way, you are creating a spatial environment. Finally, speakers literally represent QLab Q outputs. So each QLab Q output that you want to be included in your panner, you add as a speaker in panLab. Oh, I'll come back to that later. So I think that brings us to a nice point to jump right in and show you the software. So I'm going to launch panLab. So yes, so obviously on the left-hand side of the screen here, we've got one of the latest versions of QLab 4 running. And on the right-hand side of the screen, we have panLab. So for the purposes of this demo, we're going to be running panLab 2 on the same Mac as QLab. So you can see both pieces of software, but that doesn't necessarily have to be the case. panLab 2 can connect to any QLab workspace that's on the same local area network as QLab. And so, which is quite useful if you have a laptop on your production desk that you want to run panLab 2 on. You can have a whole separate screen and your own personal design setup, if you will, that you can take with you wherever you are. So it's kind of cool. But for the purpose of this demo, we're running both pieces of software on the same computer. If I click this, in fact, before I connect, let's just show you what's going on here in panLab. So the central section is going to be our panel. The left-hand side panel here is going to be a list of the QLab Qs that are in the panel at one time. And the right-hand side panel here is the currently selected queue that we're working with. That's the kind of inspector window for that currently selected queue. So let's go right ahead and connect to QLab. So panLab will automatically find any open workspaces on the network. We can select one and hit connect and link. So the first thing we need to do when working with a new panLab file is to create our first map. So we can have multiple maps within a single panLab file, but we need at least one in order to start adding speakers to it. So up pops the map manager window here, which you can also find in the toolbar. And it's prompting us to create our first map. So for the purposes of this demo, we're going to create a map called auditorium, and it's going to contain all of the loudspeakers in our auditorium. And now we've created a map, and we're prompted to create and name our first zone. So this table here contains all of our zones. We can add zones by pressing the Add Zone button. And we're given a zone when we first create a map, which is untitled, but let's call it inner zone. In QLab here, we've got a bunch of sound cues, and I've labeled 12 cues. The first 6 are inner 1 to 6, and the second 6 are outer 1 to 6. So we're going to create 2 zones on top of each other just to demo this software. So let's call this inner zone. We need to add some loudspeakers to the zone, so we can press this Add Loudspeaker button. And panLab will pull the Q output names from QLab and populate speakers with the correct names. So let's add 6 speakers, which are inner 1 to 6. And we can just drag and drop them onto the map. And you'll see that we start getting this visualization of how panLab is going to distribute audio around our sound system. So we've created our first zone. So let's see how it performs. So we need to add at least one QLab Q to our map in order to manipulate it. So we're going to pick the first one. There's a whole bunch of ways that we can add Qs into the panner. But for the moment, I'm just going to press this Fetch Selected Qs button. which will populate this list with all the currently selected queues. There's only one queue, so it turns up here. So I'm just going to drag and drop this queue onto the panel. And you'll see I've drag and drop this queue right into the middle of the zone. And you see immediately panLab starts updating our output levels. And it's distributing it fairly evenly to all 6 loudspeakers. As I start dragging the sound to the front, you'll see that we've started distributing just to the inner 1 and 2. If I drag the sound out of the zone, you'll see that the level drops off as our visualization drops off. And you can see very quickly we can start moving the sound around the zone. So our magic source, our algorithm that's working in the background there, is doing a number of things. First of all, it's figured out the geographical center of the zone, which is the point where you want to distribute the sound to all your loudspeakers evenly. And it's worked out the relationship of the speakers around that central point. And it's also, crucially, it's normalizing the output level to a constant level as you move the sound around the zone. So all things being equal, you should hear a constant sound level as you're moving the sound around the room. That's a constant sound pressure level. So that's all pretty cool. So we still have 6 speakers to add to our zone. So we can go back to our map manager by pressing map manager in the menu bar there. And let's add our second zone, an outer zone. And we're going to add 6 more loudspeakers. And we can drag them onto the map. And you'll see that panLab has selected a different color for us for these outer loudspeakers. And we can start to visualize quite nicely how the sound is going to be distributed between these 2 zones. Like so. So you can see the zone itself has got a color, and that color kind of transitions away as the zone loses influence. And that outer area of the zone is called the boundary. And we can change the size of the zone boundary right down here. So we select the zone we want to modify, and then we can just change its boundary size by dragging and making that a bit smaller. And you can now see that this kind of light pink color doesn't extend as far out. And we have more of this light blue color outside it. So now if I move this track around our zone, you can see because we're still over the inner zone, which is the topmost zone at the moment, we're just distributing to the inner zone. And as I drag the sound out of the inner zone and into the outer zone, our level is transitioning. So now we're just distributing to the outer zone of loudspeakers. All the while, the algorithm is still normalizing the total sound levels. So wherever you move the sound within your system, you should be hearing the same level. Cool. So now we've kind of dragged all the loudspeakers we want to on the map. Let's have a chat about tuning our sound system whilst using panLab 2. So the really crucial thing is our algorithm is normalizing the sound pressure level at all times. But we also need all the speakers to be outputting at a comparable level to make this work. So what I would recommend would be to set up your zone visually so you can see that you've got the right level of control over all of your outputs, and then play the sound and actually just move it around the zone and listen to it. And if you've got areas that maybe one brand of loudspeaker that's a slightly different level to other areas of your map, I'd recommend actually adjusting your gain structure away from panLab 2. So be it on an amp channel or a system processor or whatever it may be, I would adjust your gain structure away from panLab and get that set up and correct before we try and manipulate the sound in panLab. If for some reason you have some restrictions and you need some extra level of gain structure, panLab does offer the ability to offset any speaker. So we can add 10 dB to the output of any speaker, which you can see here, or we can take up to 20 dB away from the output of that speaker. And that will be a global offset. No matter what you're doing, panLab on the way out will just add or subtract however many dB to that output level. I'd recommend trying to avoid using that if you can. because it will reduce the dynamic range of the panel somewhat if you add a lot of gain or take a lot of gain away on those sliders. But it is a useful extra option should you require it. Once you're happy with how your sound system is responding, you're happy that you've got the control that you need, the next thing I'd recommend that you do is just lock your map. So you can do that using this little lock icon up here. If we click that lock icon, you can see that all of our controls within the map are grayed out, and we can't change anything to do with the structure of the map. And we also can't change any of our loudspeaker positions. I'm just clicking and trying to drag my mouse, and none of those speakers are moving now. The only thing we can move on the map are the sounds. So we kind of locked down our environment and we're ready to design some audio, which is pretty cool. So let's have a chat about integrating panLab 2 into your sound design workflow. So first of all, what I'd like to just point out is that the really cool thing about the way that we're working here is that you can choose to use panLab 2 as much or as little as you like. So you could just have a couple of cues that you wanted to manipulate in a spatial audio environment, and that's totally fine. Or if you wanted to, you could create your entire sound design using panLab 2, and every single cue has been created and manipulated using panLab 2. So the choice is yours, because we're not adding a kind of a black box of tricks to create a spatial audio environment. You don't need to change up your workflow at all. You can just carry on exactly as you are and just choose to use this software as much or as little as you like. So how do you actually go about adding keys onto the panel? So I've tried to create a whole host of ways that you can use these two pieces of software together. So the original way of doing it was just based on cue selection. So I'd select, say, a bunch of cues in QLab. I press this cue selection button, and all the cues that were selected in QLab would be dragged into panLab, and I could drag them onto the panel like so. That's the original old school way of adding cues to panLab. We have some other cool options now. So if you're working on the same computer and you're running one of the latest versions of QLab, we actually work with the people at Figure 53 to allow us to be able to drag and drop cues from QLab right into panLab. So we can just drag and drop straight in if you're working on the same computer. That's a really neat way of working. And as soon as you drag a cue in, it updates the cue output levels and places it on the panel. Another option I've got for you is panLab actually has an OSC dictionary. OSC stands for Open Sound Control, and is a way of two pieces of software talking to each other essentially. And we can actually use OSC to remotely control panLab 2 by sending network commands. So if you head to our website, Innovate Audio, which I've got here, the OSC dictionary is listed. Now, one of the most useful, there's a whole bunch of stuff that you can do. One of the most useful functions is panLab/fetch cues, which literally just presses this button, the fetch selected cues button. So why is that useful? In QLab, I've got a network cue right here. The settings of which just send panLab fetch cues to the right ports at the right IP address. And what I can do is actually create a hotkey trigger for this. For example, at the moment, I'm just using the number 1, which means that if I select a cue and press the number 1 on my keyboard, there's some kind of, I think it's a zoom bug that's making that a bit weird. But if I press the number 1, you can see that the currently selected cue or cues pulled right into the panLab panel as I'm working. So those are a bunch of ways that we can immediately add cues or show or see cues that we want to work with on the panel. One other thing that we can do is if I select these cues, for example, and add them onto the panel, I can also create a scene. So a scene is literally a snapshot of the cues as they are on the panel at the moment. So let's call this scene storm. And it contains all the cues that are in this storm sequence. So now if I have another cue on the panel that I'm looking at, and I want to have a look at all the cues in my storm sequence, I can go to scenes, click on storm and press recall, and all of the cues that are in that storm sequence, for example, are pulled onto the panel. Oh, one more handy way you can add cues onto the panel, or see cues on the panel, I should say, is we can actually do it via the currently selected group. So if you have a sound operator that's operating your rehearsal, and you want to be able to visualize on the panel and maybe manipulate the cues as the rehearsal is running, what we can do is actually press fetch selected cues on a group, and that will actually pull into the panel all of the audio cues that are contained within that group. So your operator is standing by to hit a sequence. You want to be able to manipulate that sequence in panLab as it's running. Click on the group. Oh, well, the group will be selected because that's where the operator is. Hit fetch selected cues, and all of your sound cues within that sequence are brought onto the panel. So that's quite a neat way of adding cues onto the panel. So there's a whole host of ways that you can work with panLab 2 and QLab. So we've shown positioning the sound on the panel. Obviously, we also have a level control for the sound. So if you select a cue, we have an overall level control, which is kind of the normalized level, which we call the max level, because it's the maximum level you'll ever send to one speaker. So you'll see that as I move the sound up and the level slider up and down, our overall normalized level is adjusting up and down live in QLab. So that is a way of setting a level of your sound cue. We never actually adjust the master level of a cue in QLab, so you also have that extra gain stage that you can adjust, make global adjustments to your sound cues. So I think that's it for the moment in terms of integration into your sound design. So I think it's time to have a chat about some more advanced functionality that's included in panLab 2, including dynamic spatialization we call sequences, which is a way of moving a sound around a soundscape and automating that movement of sounds. So for that, let me load up my slideshow. Find the right slide. So yeah, sequences is our the name of our functionality for dynamically spatializing sound, that's moving sound around your sound design. As I mentioned before, you don't actually need to run panLab 2 during a production, only whilst you're setting up your audio. So how do we do that? How do we actually manipulate a cue and move it around? We create a group cue, which is the sequence, and it contains a series of fade cues, which is points in the sequence that allow us to fade between different levels and move the sound around in that way. So let me demonstrate how that works. What's the easiest thing to do? Let's just have one sound cue in the panel. So here's our cue. So on the right-hand side panel here, we've got the kind of inspector for this cue. So we've got an overall level control, and we also have this whole section devoted to sequences. So let's create our first sequence. So immediately panLab has created a new sequence called new sequence, and it's given us one fade within that sequence, which is here. Let's rename our sequence. Let's call it whiz around. And you'll see that anytime I make a change in panLab, QLab is updating at the same time. So we've got this one fade, which is 3 seconds long. Let's make it ½ a second long. And what we want to be able to do is draw a path where we're moving the sound around a space. So we have a draw path button. When I click that button, the name of our fade changes to give us an instruction, which is move this object to record movement automation. So as soon as I click and hold and drag, you'll see that panLab is showing you that we're creating some fade cues at points along our map, and we're recording the position, where I'm moving the object, and also how fast I'm moving. And all of that information together is printed into our sequence in QLab. So I was talking and moving the sound there for 17 seconds. So the sequence lasts about, well, 18 seconds. The sequence lasts 18 seconds. And you'll see that the speed of movement, which is how fast the fades happen, is relative to how fast I was moving the mouse at the same time. And all of those fades are printed within this group queue in QLab, so we can play it back later. We can do some pretty cool stuff to manipulate this. Say, we love that sequence. We thought it sounded great, but it's a little bit too slow. Whatever it's going with is sped up a bit. We can actually change the total duration of the sequence by clicking on this text field here with duration. So it's at the moment it's 18 seconds. Let's make it 10 seconds. If I hit 10, we can actually change the speed of this sequence in two ways. We could either make it 10 seconds and adjust the speed so it's a constant speed of movement rather than a slightly jittery movement that I was drawing with my mouse. Or if we like the way I was drawing the sequence, we can actually adjust the whole thing proportionally. So say the sequence started off really quickly and then slowed down, we might want to keep that proportional adjustment. So if we hit adjust proportionally, that's exactly what it's going to do. And it's going to create a sequence that's roughly 10 seconds long, and it's adjusted the sequence time accordingly as well. So that's really nice. What else can we do with sequences? Oh, yes. We can also copy sequences onto other queues. So at the moment, this sequence is, the target of the sequence is the river, but say we had a whole bunch of queues that all wanted to do the same thing. We can do this in a number of ways. If I literally select the sequence and just hit copy, if I pull up another queue into the panel, say acquired dreams, I can paste it, and it will paste that exact same sequence onto another sound queue, and that will then manipulate another sound queue. Also, any panLab 2 file also comes with a sequence library, and so we can drag and drop that sequence into the sequence library and populate a whole library of movements that we might want to add onto queues. And let's put another queue into the panel, plop in our sequence library again, and copy and paste that, and just drag that sequence onto another queue. So now we have that sequence 3 times in the panel, all related to, 3 times in the panel and also QLab, all related to different queues. So we can manipulate, we can create sequences for any number of queues that way, which is pretty neat. So I think that covers sequences. So let's move on a little bit to derived outputs. So derived output, we really created derived outputs in order to deal with low frequency energy components of a spatial audio sound system. So you can think of a derived output as an additional QLab Q output that we want to send level to, and the level that we're sending to that output is derived from the level we're already sending to any number of other outputs. As I said, it's useful for managing sends to other subsystems. So that doesn't have to be LFE components. It could be any other, some fills or whatever it is that you want to additionally send audio to. It's got some other uses as well, but I was mainly thinking about low frequency energy components of a sound system. So let's demo that in action. So to adjust derived outputs, we need to go back to our map manager and we need to unlock it. And we've got this assign derived outputs button up here. So let's click that and find out what happens. So we can have 8 derived outputs in any one map, and they can each could be derived from different things. Actually, before I do this, what I need to do is go back into QLab and show you that hidden in output 13, we actually have an output called subs. So let's go back to our map manager. So we're going to create a derived output called subs. Let's call it LFE. That's the name of our derived output, and it needs to have a QLab output that it's going to be routing audio to. So the actual QLab output is called subs. So let's call it subs. It needs to exactly match the name of that output. That's how you're creating the link. And let's hit this assign button, and we're now going to assign the outputs that we're deriving this output level from. So for the moment, let's derive it from all of our inner zone loudspeakers, 1 through to 6. Hit done. So I already showed you how to adjust the overall level using the max level audio control, which we can do right here. That's a different key, so let's just have a look at that. So you can see that we're manipulating that output level. We also have a little mixer icon in relation to every single audio cue. And if I click on that, we have the max level still, but we also have a bunch of other level controls that we can manipulate. So we've just learning about derived outputs. So we've got these 8 derived outputs, and we can think of our derived output as well as like a post-fade auxiliary send on a mixing desk. So if I was to turn the LFE level up for this output, you can see that it's hitting -8 because well, it's down 1 dB. Let's turn that to 0. There we go. It's -7.4 because this sound cue is within this inner zone. We're deriving the output level from the total level we're sending to the inner zone, which is -7.4 dB at the moment. And as I move this sound around the inner zone, you'll see that the level we're sending this to the subs is constant. It's at -7.4 dB. And if I move the sound outside of the inner zone, it takes a while for QLab just to draw the updates, but you'll see that the level that we're sending to the sub diminishes as the level we're sending to the inner zone diminishes. So that sub output level is derived from the level we're sending to the inner zone. So that's quite handy. And you've got that level control on a cue by cue basis for every single cue within the panel, within the map, sorry. But it's got a bit more of a use than, it's kind of a bit more useful than that, because if I create 14 visible channels in QLab, you'll see we've also got a rear subs output. So if I go back to our map manager and our derived outputs, let's create a rear LFE derived output and call it, we need to send this to rear subs QLab output. And this time with our main LFE output, let's just derive that from the inner zone 1 and 2. And our rear subs output, let's derive that from 3, 4, 5, and 6, for example. Now, if we have a look at this cue again and turn our rear LFE up to 0, you can see that, oh no, sorry, I'm going the wrong way. As we move the sound back in the zone, so if I'm at the front of the zone, we're just sending to the front subs. And as I move the sound back, that transitions into the rear subs as I'm just sending audio to those rear loudspeakers in this example. So you can see that's quite a powerful way of manipulating how we're sending audio to subs. You could have more derived outputs with more subs than that if you wanted. You could have quad subs and manipulate your output level to the subs by all 4 if you wanted to. So it's quite a powerful feature that we've added to the software. Great. Oh yes, one final thing before we go on to the Q&A. Let's say that this setup that we've got going on here, we've got a central stage in the rounds, and that inner zone is, say, a central cluster around the stage, and our outer zone is surround speakers behind the audience. We may want to place a sound right in the middle of the stage here, and we may not want it to come from that inner zone of loudspeakers. We might want it to be panned into the center of our surround ring of loudspeakers, for example. So we can do that. We can achieve that using panLab 2 as well. So I don't know if you noticed, but within our map, we also have zone opacity here. So on a cue by cue basis, you can adjust the opacity of any zone within your sound system. So by default, with each zone is at 100% opacity, but we can actually reduce the opacity of the inner zone, and you can see live as we do that the output level is transitioning from the inner zone to the outer zone. And I can turn that inner zone off completely. And now, even though this sound is right in the middle of the inner zone, we're actually just sending it to the outer zone, our speakers, and we're ignoring the inner zone. So on a cue by cue basis, you can really manipulate how you're distributing sound around your sound system. So there's a bunch more stuff that I can show you, but I think it might be useful at this point to throw the session open to a bit of a Q&A, because there might be some things that I've kind of skipped over that you're interested in. So Oscar, is there anything in the chat currently?
Yeah, so Jeremy's asked, is there a way to update the QLab group with a new timing? This is asked earlier on in reference.
Is there a way to update the QLab group with the new timing?
Sorry, that was when you were doing the sequences and you changed it from a 17-second to a 10-second. At least QLab on the display didn't update immediately, but somehow you did that, and I might have missed your one click that.
Yeah, I didn't actually do anything. I think that might be a QLab bug.
Oh, okay,
how it displayed it would have updated immediately. So which ones? Let's just change this again. So let's make this 15 seconds and adjust proportionally. So one of these, yeah, so that's changed to 15 seconds straight away. I think it might be a slightly weird bug because I'm screen sharing on Zoom. I've noticed a couple of little glitches with Zoom screen sharing with things like that. Might be a Mac OS bug with not updating all of the windows in the background, but yeah, so it will have updated. It will have updated immediately. And in fact, the timing here it's sometimes off by like a couple of milliseconds, but the timing is updated from QLab back to panLab as well. So that would have happened straight away.
And can you do this stuff live from another? I'm thinking about a kind of advanced situation where we may have locational information coming in that could be coming into panLab with OSC, and maybe that translates it into spatialization. And QLab is obviously only updating the fader positions rather erratically, at least on Zoom. If it's being updated live through OSC, does it does it step, or is it immediate?
So QLab isn't really designed all that brilliantly to update with a lot of OSC really quickly. So what I've actually found is I've had to really filter and slow down the rate of OSC that I'm sending over to QLab with panLab in order to allow QLab to keep up. So you do get, if you're trying to do something live, you do get a little bit of stuttering. Because if I did send like full pelt OSC over to QLab, even if it didn't lock up the interface, QLab doesn't actually respond all that quickly to incoming OSC, at least not at the scale that you'd need to make those smooth transitions and fader levels. So typically I'd advise against doing that, and it'd be better to pre-record them as fades, and then you get a really smooth transition around as you're moving a sound around. That's more of a QLab limitation at this stage, I think.
Oh, that makes sense. And can you use this on microphone inputs as well as audio? Mm-hmm. You can.
Yeah.
Awesome.
So it works exactly the same on mic inputs as audio inputs.
Yeah, those are my big questions.
Cool. You can update the position in panLab using the OSC dictionary. So you can update the X and Y position of cues, but that feature wasn't really designed for those reasons that I mentioned. Wasn't really designed for live use in terms of with trackers. It's more designed for if you wanted to like step away from your production desk and use maybe like touch OSC to manipulate a cue from somewhere else, you can use OSC to do that.
Is opacity also available via OSC?
That is a very good question. If it isn't, it can be. I think maybe it isn't right now, but I'll definitely look into that.
Yeah, because that could be a great way to do height.
Yeah, exactly. It's sort of half the way that we were. That was our kind of one of our solutions for height adjustment is zone opacity. Are there any situations where panLab would need to be active whilst running a show? No. There's no reason why you'd need to have panLab active. The only reason you need to have panLab active is to edit any of the edit anything spatial to do with any of your audio cues. If you just want to play it back, you don't need panLab at all.
Question from Jeff. For the derived outputs, how does the panel determine the crossfade between zones? Is this based on the same normalization algorithm? Is that adjustable?
The derived outputs, how does the panel determine the crossfade?
Like how does it know how many speakers? Is it just the nearest? Is it the nearest 4? Is it based on a radius? I think that's...
So the derived outputs it's literally just adds up in decibels the level you're sending to the speakers that you're deriving the output from. So so the total, if you're in the middle of, well, let's just change the zone opacity back. Well, you can see this. So because we're sending, this is a total of minus 7.4 divided across these 6 outputs, is like minus 17 to each output. If you add all those minus 17s together, you get to minus 7.4. And then if I just move the sound, so it's just across the 2 speakers that are at minus 7.4, you'll see that's at minus 7.4. If I turn the zone opacity down, these numbers are going down, and so our total amount of power that we're sending to these speakers is going down, and so the amount of power that we're deriving it from is going down as well, and so that figure that we're sending to subs is going down. So it's all relative to the amount of output power you're sending to the speakers that you're deriving the output from.
Oh, cool. Yeah, that clears it up. Thank you.
Cool, no worries. And you can actually derive outputs from themselves in a way. So you can have just because in this example I'm sending to an additional output, but say you had a telephone on stage that had a little ringer inside it that you were sending a ringtone to, and you wanted to just to beef that sound up. Say you wanted to send that ring to all of these inner 1 to 6 loudspeakers, you could derive that ring and put it into a number of other speakers, and it would just kind of add the level on top of the level you're already sending there, if that makes sense. So there are more complicated ways you can set up derived outputs as well to kind of make the most of, to add additional level to other speakers. You can play around with it and figure out what you can do. How important is it the speakers on the map are accurately distant from each other? Is there an option for importing a ground plan? Those are good questions. In terms of ground plan, yes, there is. So if you go back to Map Manager, you can add a background image here. You can add any image you want, and that will appear behind the image in the panel. I used to have one that was just called Plan. Yeah, I can search for it. I don't know if it's on this Mac. Oh, here it is. Great. So you can see that you've got a plan behind the panel, and we can turn the visualization opacity down so you can see that better, and you can place speakers exactly wherever you want them on a plan. In terms of the physical distances between speakers, it doesn't matter at all, as long as they're relative to where they are actually in a space. But I mean, they don't even need to be. Like if you want to do something a bit wacky, you can put speakers wherever you want on the plan. But if you want a realistic representation of where that sound is, it doesn't need to be perfectly proportioned. There's no delay panning going on here. This is just level panning. And so the closer you can place a speaker to where it actually is in a space, the smoother experience, the better experience you'll have. But it's been kind of designed that you can just throw this up really quickly and get going. But you can also be really precise. So you can actually just type in the XY coordinates between 0 and 1 and line speakers up perfectly in squares or hexagonals or whatever shape you want. You can be really precise about it too.
So on a Q to Q basis, or even globally, how do you tell that this sound object, this Q, has this larger spread? Like how much is it spilling out into the whole space versus how tight is that pattern? Like how do you adjust that?
Okay, cool. So the way our algorithm works is essentially we work out the center point of a zone mathematically, and then we work out the relationship between all the speakers within that zone. So in terms of how we spread a sound around, when you're on the outer edge of a zone, let's make this a bit simpler, just demo purposes. Let's turn the inner zone opacity up and the outer zone down. So we're just dealing with one zone. So we're just looking at these 1 to 6 loudspeakers. So because we are right in between these two speakers, we're just going to be panning the sound between speakers 1 and 2. As we move the sound towards the middle of the zone, the spread of where that sound is in relation to the zone is widening out. So what that actually means we're doing is we're calculating the sound as if it was taking an arc. It wasn't just one point, it was like an arc here. And so as we add those together, you can see that we're actually feeding into the outputs 3 and 6 because they're the next outputs around. Until, if I just move really slowly until you get right into the middle of the zone, until we're actually just, we're treating the sound as if it's within that entire zone, and that results in us panning evenly between all loudspeakers in that zone. So to change the spread of a sound within a zone is literally just how close to the edge versus how close to the middle of a zone you are.
Well, but so if that object though was right on top of input 1 or inner 1, but you wanted it to be spread out at like -10, -15, whatever, to give to the rest of those inner speakers, to give a more not as focused of a localization, is that sort of spread possible?
Yeah, so that is literally what the algorithm is doing for you. So as you move that out, you are, so here we're right on top of inner 1, so we're pretty much sending just to inner 1 if you get it just
right. But right now it's not sending to inner 4 at all, or inner 3.
Sure.
Like, what if you wanted to spread it out more?
Sure. So yeah, so then as we move it in, it is spreading out more, as in it's spreading. We're now sending mostly to inner 1, but also to 1, 2, 5, and 6. Is that kind of what you're saying?
I guess I'm not asking the question properly, but I guess it would be more of a derived, maybe it would be a derived thing where it's only in 1, but it's sending to all the other ones at -20.
Yeah. So
or whatever.
I think I see what you're saying. So it would be a neat feature if we change the size of the object. So at the moment, the object is just one pinpoint in space, and our algorithm is making that calculation a bunch of times to essentially spread the sound out amongst more speakers. But yeah, it would be kind of neat. Maybe a more diffuse. Yeah, maybe it would be something that we could work on where we essentially make that object a bigger object, so it's diffused it out amongst more loudspeakers.
Yeah, because imagine a wind sound as opposed to a bird sound, and you want a wind to sort of float around in the space, maybe as stereo or quad, but you have 30 speakers, and you don't want the wind to just go to one speaker at a time. You want it to go to this quadrant of the theater or the space.
Yeah. Oh, no, I totally see what you're saying. So at the moment, I would typically just naturally, because I've designed a bunch of shows with this software, so I would naturally just, instead of putting the sound there, I would move the sound here, and that would, to me, would spread the sound out amongst more loudspeakers. But what it won't do, which is what I think you're getting to, is that it won't also spread it out to the outer zone of loudspeakers if I move in here.
Or even to the rest of the inners, if it's right on top of it.
Yeah, exactly. If it's there, but it's right on top of it. Yeah, so it's our algorithm is kind of doing that as how it works in the background, but it's not, but you kind of have to move the sound in order to get that spread, rather than you're saying, I want the sound to be there, but I want it to be more diffuse around more loudspeakers. Yeah. That's definitely something that we can work on. But yeah, as I say, so you're kind of getting that effect by moving it away from a single speaker itself, and that is diffusing it. So if you have a look at the output levels there, it's diffusing it to 2, 5, and 6 because they're the closest loudspeakers of that. But you are moving the object away from there, you're putting it there. But yeah, I mean, typically that's how I would work. But yeah, there is an argument that you could create a kind of a size of an object as well. So yeah,
especially if you've made sequences already that move the sound around, and you just say, oh, well, that sounds great, but I want to not have it so specifically in each speaker, but I want to have it more diffuse. But I want the motion to be essentially the same.
Yeah, totally. So yeah, no, that's a very valid point. With all this stuff, I'm always, finding ways of doing this where you're not adding that many extra layers of complication, because
Yeah,
we really want this to be something that's really accessible to a lot of people. So there's a few things that we've kind of looked at and gone, actually, that does add some value to a small subset of people, but it also makes it more complicated to a larger subset of people. So that's the kind of balancing act when you're developing something like that. But
well, if you've ever met me, you'll know that I'm always looking for the small subset.
So, but it's a very valid point. But yeah, have a look at it. It's just a way of developing it in a way that doesn't add complication that will confuse a larger subset of people, I suppose. So yeah, cool.
Question from Jeff about mono versus stereo.
Cool, yeah, so that's a good point. So again, in a bid to kind of keep this as simple as possible as a piece of software, we are putting all of the decisions about which, if a multi-channel piece of audio, which channel you send to which loudspeakers, up to the designer themselves. So you'll see that with this stereo file, I've actually kind of monoed it up using the cross points. I can't remember why I did that here, but typically I'd send the left channel to my left loudspeakers and my right channel to my right loudspeakers. And that's completely up to the end user, how they want to deal with the different audio channels within their sound system. Again, it's another one of those things that's come up a few times, and it's simplicity versus feature set kind of debate. And I really wanted to keep the software so it was just manipulating the Q output levels sliders, so you can immediately see, if you need to, what it's doing without having to worry about what it's doing to your cross points and all the rest of it. So it's up to the user.
Well, so you have to do the cross points yourself before you drop it into panLab.
Sure, yeah, just like with any piece of audio that you might be working with in QLab, you set your cross points up however you want them, and we don't manipulate the cross points at all. Any other questions? Oh.
Yeah, question, can a speaker be added into a zone after cues have already been printed?
Yes, absolutely. So typically advise you try and set your sound system up before you start adding cues, because it can get a little bit messy. But yes, you can add speakers all the time, and you can add cues all the time. And there's what we can do is update. So typically what we're actually doing is we'd update, if we moved a speaker or added a speaker, we would immediately update any cue that was currently present in the panner at that one time. That's just to keep it, again, it's just, you immediately know what's changed. We're not changing anything in the background that you're not immediately looking at in the panner. But you do get this little warning triangle pop up here. And it's just, this dialog just basically tells you that something on the map has been updated. So this is turned up because I started adding derived outputs after I'd already added some cues to the map. So because those cues were added to the map in the backgrounds, they haven't actually been updated in the panner for our new derived outputs. In fact, it's not going to make any difference because we're not sending them to the derived outputs anyway. But say we moved a speaker, none of those cues that are in the background in the panLab file will have been updated with our new speaker position, for example. So this dialog is just telling you to stop all your currently running cues, save the QLab workspace because you're about to make a big change, and then update all levels within QLab. And in the background, we're actually updating all our levels with our new map, how it's currently set up within the workspace. And all those cues are now updated in the background because you made a change to the map. So it's better, if possible, to not make any changes to the map after you've started adding cues. But if you do, there's a process where you can basically ripple that change through to any cues that you've already had in the map.
How is it keeping track of which cues have been associated with panLab?
How is panLab keeping track of that?
Or either one, like how do you know, looking at either the QLab file or panLab, which queues are connected, which queues are related?
Okay, cool. So if you, I mean, just on a day-to-day, like in a quick way, if you select some queues, the queues that are updated will appear in the panel, and if we select a queue that's not been added into panLab, it won't appear in the panel. It'll just appear in this list, and you won't get that little level icon.
Oh, as an audio object, you mean?
Yeah, well, as an audio object in the panel, that's correct. You do have a queue manager list, which shows you every queue that's been added to panLab, and you can select them in QLab. Well, there's definitely a Zoom bug going on with updating QLab. But yeah, so you can select a queue in here and see where it is in the QLab file. So there's, and you can then click that button and remove it from panLab. So there's ways of managing the association between the two. But well, I suppose you could do something like change the queue color of the queue in QLab, but essentially all that relationship is just stored within your current panLab 2 file. So whenever you go back to panLab, you can see those queues again in the future.
Okay, yeah, so that's a separate, it's a whole separate file, the panLab file.
Exactly, yeah. So so at the moment it's not saved, so it's just called untitled. But if I just go file save, where should I put it on my desktop? A panLab.
I've got a big question for you.
Sure.
So Jeff and I are working on something where we're going to make a show in one venue, and we'll take it to multiple different venues with different speaker layouts. Would we be able to build everything using panLab and then just copy that, make a new map, move the speakers around, update the whole QLab file in one pass, and it would update all those locations?
Yeah, so it's a tricky one. So
I tell you, I'm the small use case, but I'll break it.
That's a good one. So I've built a little bit of functionality in to help you on a basic level, which is, for example, we've built this show in a venue and we've got these 6 inner loudspeakers here. And let's put this sound into the middle of them. So we're just looking at this, right? We've got these 6 loudspeakers. If we go back into the map manager, say we go to another venue and we don't have loudspeakers 3 and 6, I can uncheck this active checkbox, and you'll see that my distribution of sound has taken out 3 and 6 and has redistributed that level to 1, 2, 4, and 5. So essentially,
that's show wide, or that's for that queue?
Well, it would need to be updated by going to this map updated screen and ripping that change down to all of the queues that are stored within the panLab file. At the moment, it's just for that one queue because that's the queue that was in the panel at the time. But you could go back into there and ripple that change down, and that would copy through to every queue within that you've manipulated in panLab within the connected workspace.
That's great.
But in terms of like repositioning your speakers and everything, yeah, you totally can do that. And again, you can ripple all those changes down. You just have to be really careful about where you've actually positioned all those queues in relation to those speakers. Like if you make a really big change and then ripple that change, it'll have to be correct for where all those speakers are. So you just have to be quite careful about it. But there's no reason
why.
Undoubtedly,
it would take some tweaking, but yeah. For a whole new venue, if you go from a rectangular venue to a circular venue, it's totally different, but it would get you in the ballpark, and then you could tweak it.
Yeah, totally. Yeah, so it's not. Yeah, it wouldn't be a completely seamless transition, but it would certainly get you like 70% there. But we've specifically built that one piece of functionality for the example of, yeah, as you say, so you're building a tour and you start off with an all singing, all dancing, 6-point surround system, and then you move to, it even works all the way down to the stereo, right? So if I go in here and disable 5, where are the other ones? 4 and 5. It's just literally put all of those speakers back into, say that's a pros, back into your pros. And its normalized level is the same. So the relative level is the same. It's just you've just closed down all that space back into the pros.
Yeah, cool.
Cool.
Easy way to do a rehearsal mix down too.
Yeah, exactly. Yeah. So you can work, you can create a rehearsal, you can design in your rehearsal room and just be working in stereo and just uncheck those boxes or check those boxes, and suddenly you've put everything into surround.
So then if you were to try to, if you needed to create like a submix in stereo for some sort of like, live feed through the internet, you'd probably just use derived outputs though, right?
Yeah.
Okay.
You'd use derived outputs. That's what I'd suggest. And what you can do is, so there's a preferences window. So if we go in here, you can see that I can set default levels. So my default level for my main normalized max level, I tend to set it at -10. And all of these are turned down. But say we always wanted derived output 7 and 8 to be our mix down, you could set those as a default level for all new cues of like, say, 0 dB or whatever it is. And then and set those derived outputs up, and then every time you add a cue, you're already sending to those derived outputs. So you don't have
those are the 1 through 8 is derived outputs and not the speakers that you've labeled 1 through 8.
Exactly. These are your 8 derived outputs that you get in a map. So every map gets 8 derived outputs.
Probably should say in the thing their default derived output levels, so it's clear.
Oh yeah, that's right. Fair enough. Yes, they should be derived output levels 1 through 8, not out 1 through 8. But yeah, you can do a bunch of stuff in here.
One last question regarding kind of going back to the sequences with the automation, and you had drawn that line in real time and then made the adjustments and then you saved it. I maybe had forgotten this point, but you can go in and just adjust every single node fade point and then sort of reassociate it with QLab again, right? So going back to Jeremy's question about if the venue changes and we get 75% there, oh yeah, you just did it right in front of me.
That's right. I was just putting something in to demo it.
Yeah.
So absolutely, all of these are just objects in the panel, and you can move them around, and then you can.
So then, what if we decided, like, say there were 15 cues that all followed the same pan motion, and we thought, okay, we fixed one of them, but we want this to happen, to ripple through all the other 14 cues. Do we then resave that as a new sequence and then have to reapply that, or how does that work?
Yeah, what would be the best way of doing that? I guess what you'd need to do is just literally copy and paste that, and then there's no it's like a sound, it's like a QLab cue, right? It's the same thing. So if you copy and paste a cue and in QLab, purely QLab, and you made changes to one, then you need to make those same changes to the other cue. They're not related anymore. But I mean, you can certainly easily copy and paste that new sequence or new version of the sequence that you've got, and then just paste it onto your other cues, and it would do that for you very quickly. But yeah, it would
From
be
your sequence library.
Yeah, through the sequence library, exactly. So we've got this new sequence called new sequence, and you can see it's different to whiz around, and we can then drag and drop that onto other cues and place those in the right point in the QLab workspace.
So you can't edit in the sequence library and have it automatically ripple to associated cues.
No, the sequence library, so again, that's just another copy of a cue wherever it is.
Yeah.
There's no association. It's just like copying and pasting from one place to another. I forgot to mention, actually, just whilst we're pointing stuff out about sequences. So let's create a new sequence. Just another little bit of functionality. So let's play this sound. So this sound's running so we can hear it. Let's create a new sequence whilst it's running. And let's call this demo for whatever reason. And let's just make this first fade like half a second. So the sequence is, the sound cue is running. We're 20 seconds or so into the sound cue, and we want to start drawing this automation path. Let's just make it short to make it easy. Because the sound was running whilst we were drawing the automation, we would have heard that movement live if we were listening to it. we might want to replay that sound at exactly the same point in time next time we run that whole sequence. So panLab has remembered in the background the time where you started making the sequence, and it's asking us if we want to add that in as a pre-wait time to the sequence. So if I go ahead and hit yes, you'll see that I was 24 seconds in as I was talking, and it's added 24 seconds to the pre-wait. So now if we played both those cues back at the same time, the original sound and the group, the result would time out at exactly the same point in time as when we were initially recording the audio.
Cool. And if you adjust that pre-wait in QLab, does panLab know about it, or how does it keep track of that?
It doesn't actually keep track of that at all, because it's literally just a pre-wait.
It's just a one-time thing that
it's just a one-time thing. You just
Yeah.
happen to be running the sound. Hey, do you want to save that as a pre-wait? And you can just change that time. It doesn't make any difference. There's no pre-wait column in panLab. It's just you've just created a pre-wait.
Cool.
I just forgot to demo that earlier. Oh, and the other thing is that we keep track of whether the cues exist in QLab. So you can see that there's some errors here because these cues don't exist in QLab anymore, and we can sync those back to the workspace. And that will just push any sequences that aren't currently in the workspace back into the workspace in the background. So if I accidentally delete some cues here, you'll see that they're marked as unavailable, and you can sync those back in.
That's kind of fantastic.
There you go.
Yeah.
So we're always keeping those two bits of information in sync.
And these could run on separate computers as well, since it's just OSC.
Exactly, yeah. So that's exactly right. So what I tend to do personally is I'll have this on my production desk on my own designer laptop, and then I'll be syncing in. So I might have a screen share of my QLab operators QLab, and then I'll just have on a separate screen panLab, and they just run as if they're on the same computer. It doesn't make any difference. Cool. Any more questions? Thank you so much for joining us, and really nice to chat to you all, and have a lovely Christmas and a happy New Year. And yeah, thank you very much.
Thank you. It's
Great.
brilliant.
Thank you guys. Appreciate it.
It's no problem.